Once more, in this video we'll be practicing how to find an equation of a quadratic sequence. This is an introductory video to quadratic sequences. Now, given the formula 1 4 9 16, there are two methods which you can use to find an equation or the nth term of a quadratic sequence. The general form of a quadratic sequence is that Tn is equal to an squared plus bn plus c. An examiner can say the general term, he can say the nth term, or he can say the defining formula. They all mean the same thing. This means Tn, the sum to n, the nth term of a quadratic sequence. You can say the general term, or you can say the defining equation or formula. So in this equation, in this video, I'm going to be using the simultaneous method. What you have to do here is to look for the second differences. Let's do it. The sequence is 1 4 9 16. It's 1 4 9 16. Now what we're going to do is we are going to look for the first differences. Remember, wherever there's a difference, there is subtraction. What we will do with the difference, we will say T2 minus T1. This is T2. This is T2 and this is T1. This is T3, this is T2, and this is T4 and this is T3. Now, the way we're going to do it is in this form. Now, I'm going to say that 4 minus 1 gives us 3. 9 minus 4 gives us 5. 16 minus 9 gives us 7. Then, what I'm going to do here, I'm going to look for the second differences again. These are the first differences, meaning the first subtractions. I'm going to look for the second differences. In this case, I'm going to say 5 minus 3 is going to give me 2. Then I'm going to say 7 minus 5 is going to give me 2. Then this is the second difference. Now, can you recognize the difference between an arithmetic sequence and a quadratic sequence? Now, in the arithmetic sequence, the first differences were constant, but in a quadratic sequence, the first differences are not constant, but the second differences are the one which are constant. By constant, we mean they are the same throughout. So what we're going to do here, we have our defining formula here. It is Tn equal to an squared plus bn plus c. The first thing we will do in all cases when you're determining the equation of a quadratic sequence is that we're going to say that 2a is equal to the second differences. We will say that 2a is equal to the second differences. Now in this case, what is our second difference? Is 2. So we're going to say that 2a is equal to 2. Now we'll divide both sides by 2 and we'll get our a as 1. This means that a is equal to 1. Then we're going to go to our defining formula, the Tn equal to an squared plus bn plus c, and we're going to plug in the value of a. Let's do it. Now we're going to say that Tn is equal to a, which is 1. We can just drop it. Then we can write n squared plus bn plus c. Now, what you have to understand here is that we are going to take two terms. In this case, we're going to use the second term and the third term, and we're going to plug them into this nth term formula. Now, what is the second term in this case? The second term is 4 and the third term is 9. So I'm going to plug 4 here, and I'm going to plug 9 here. Now, what does T2 equal to 4 mean? It means that we find 4 on the second position and we find 9 on the third position. So what I'm going to do here, I'm going to say that N stands for the position. So on N, I'm going to plug the position in which I find 4. Then I'm going to say that Tn, let me write it, Tn is equal to n squared plus Bn plus C. Now what is my Tn? Tn stands for the value that is found on the certain position. So Tn is equal to 4. And then n stands for the position. This is T2. So n, we're going to plug 2. This means position 2. Then it's going to be 2 squared plus B times 2 plus C. Then this is going to be 4 is equal to, then 2 squared is 4 plus B times 2 is 2B, then plus C. Now we're going to say 4, we're going to take this 4 to that side. Then it's going to be 4 minus 4 is equal to 2B plus C. Awesome. Then we can simplify this further. 4 minus 4 is 0. 0 is equal to 2B plus C. Since C is alone, we can take the 2B that side to the left side, and then C is equal to negative 2B. Remember that whenever a number or a constant crosses a sign, it changes its sign. Then it's going to be 1. Let's do it. This means that this is our equation number 1. Now we're going to go back to the third term, and we're going to come out with equation 2 from the third term. Let's do it. Now I'm going to write the equation again as Tn, sorry for that, Tn is equal to n squared plus Bn plus C. Now Tn, I'm going to plug 9 because Tn stands for the value, and then n stands for the position, which is position 3. I'm going to take 3 squared plus B times 3 space plus C. Then I'm going to say that 9 is equal to, what is 3 squared? 3 squared is 9 plus B times 3 is 3B plus C. Then what I'm going to do here, I'm going to simplify it. It looks like it's the same case. I'm going to take the 9 to the other side. 9 minus 9 is equal to 3B plus C. 9 minus 9 is 0. 0 is equal to 3B plus C. Now, we're going to take C, the 3B, to the other side. We're going to leave C on its side again. Then negative 3B is equal to C. This is our second equation. Now, what we can see here is that C is equal to 2B and C is equal to negative 3B. So we can equate the two. We can say that equation 1 is equal to equation 2. Then I'm going to say that negative 2B is equal to negative 3B. From this, we can see that the two variables cancel each other and the solution is lost. This means that we don't have the value of B in this case. We don't have the value of B and we don't have the value of C. Now this means that Tn is equal to n squared. There is no B, there is no C. And this is the equation of the quadratic sequence. Thank you for watching. Bye bye.